we are about to start the next session, and I'm Kulderas from the National Archives of Estonia, and I try to do my best to chair this session here. So what you are following now is then session 2, stream 1, digital preservation in 2021. If you are more interested in listening to things that happened in 2019 or things that still happen in 2020, then the links to the other streams as well as stream 4 are in the chat box. But here in this session, we'll have 5 excellent presentations on different aspects of the things in digital preservation that will influence us more in the coming years. I would also like to draw your attention to a little change in the agenda. So we'll have flipped the 2 starting presentations, and as such, I'm giving the floor, the virtual floor, to Natasha Milic-Freling from Intact Digital Limited to talk about taking access to the next level, legacy software hosting and remote use of archived content. Natasha, please.
Thank you very much. Just start there. I'm very pleased to present to you today on the issue of access to digital content, because that has been kind of my preoccupation for several years now. My name is Natasha Milic-Freling, and I am CEO and founder of Intact Digital. I have been involved with preservation issues for a while now, primarily through Planets and Scape projects at the beginning, and now with the UNESCO. So today I will tell you more about what we have done in order to ensure that digital archives records can be accessed. Importance of digital archives is extremely high because of the transfer knowledge function that they have across time. And we know that the value of the archives really is in providing the right information to the right people at the right time. And now in the times of this pandemic, so people are seeking for ways to find the most effective vaccine or medication. This is about understanding what happened in the past and how we can use the past records to innovate in the future. And I'm using this bioanalysis example just to illustrate to you how part of the industry that are really, really keen on access to digital records, how they manage it. In bioanalysis, normally people have instruments, very sophisticated instruments that they use to process a specimen, and then the raw data from these instruments get moved to specialist applications. The specialist applications provide data analysis, and all of that together goes into a digital archive that stores full information about a study that has been completed. Now, this information has to be accessible and verifiable at any point in time, which means that archive is continuously accessed, and there's ongoing integrity checks, and most importantly, there is a check that the analysis of the data actually is stays faithful to what was done originally. So the industry itself has adopted very strict guidelines. These are called good laboratory practices, and these good laboratory practices must be followed. And then there are organizations like OECD, Organization for Economic Cooperation and Development, that helps organizations interpret these principles and then put in place practices. And I'm just here highlighting 2. One is about importance of having the raw data from those instruments, analysis of specimens put in the archive, and then being able to look at the data and see the same analysis. And for that, they also advise putting software, preparing software and putting in the archive if necessary to have these ongoing checks. So how does this normally work? And so the archive has raw data, preserved digital objects, metadata. They have preservation workflows. All of that is within the archive. But then there is this PC that has the software, and then the raw data is exported from the archive into the PC, and then whatever is seen on the screen at that moment, meaning the results of the analysis, need to be compared with the report that has been preserved. So this is the validation, and that's done constantly. On a monthly basis, they may be doing integrity checks, and then on a 6-month basis, they will be doing software checks. I'm mentioning this because this is an excellent example where things work brilliantly most of the time, until the time comes when it starts creating headaches and challenges. And that's the time when the operating system changes. Even if the hardware stays, when the operating system becomes unsupported, then things become much more difficult, because the operating system then causes the security threats that need to be mediated by isolating the PC. At the moment when a PC is isolated, then the files that need to be transferred from the archive into the PC, that requires physical access. So everything becomes much more difficult. And then, of course, now if you look at the rate at which operating systems are becoming unsupported, most recently Windows 7 in January 2020, it doesn't have any more even extended support. So now all the studies are being affected since 2009 to 2020 that use the software released in that period. If you look at even further back with Windows XP, which was released in 2001, the support ended in 2014. So we now have 2 decades of studies, and these 2 decades of studies are being affected by the obsolescence. I just want to mention, just to put this in context, we had a SARS epidemic in 2002, and the records from that time are now 18 years old. And that is the time of XP, and that is the time of Intel, chip number 4. So that was a different sort of era. The question then is, can we now, when we're struggling with COVID-19, go back to those records? Can we go and allow and enable scientists all over the world look at the data that is relevant? And fortunately, yeah, the answer is yes. And here I'm putting the implementation that actually allows that. On the right-hand side, there is what we call it a software library. This is the environment in which the software is installed in virtual machines. And this is the environment in which data needs to be brought in order for the data to be reprocessed with the original software. I'm using here a software called Analyst 1.4.2, which actually is used in viral analysis. And then anybody can come to their PC and access the installations from their browser. And so I will now just demonstrate to you quickly how that's done, just to explain how it is possible to get the data in, even though you have to mediate a couple of risks. The XP installation has to be isolated because it's kind of vulnerable, and that data still need to reach that virtual machine effectively and easily for end users to use. So this is enter to a portal of the software library. Which then brings people to a place where they can find these virtual desktops. So I mentioned there is a desktop that I will need to transfer the data, and this desktop needs to talk to external world. Desktop, it has to be, say, on contemporary operating system that is supported, and then the desktop will take me either to a portal where repository where I may have my data, or it may take me to an archive if I have access to the repository. And then at the same time, I'm going to start a desktop. This is a desktop where I need to transfer the data to. This is the XP environment in which actually we have the application running. So if I go here to the transfer desktop, I have 3 areas where I can put the data. Say, here's my browser. I can get out and bring the data in. There are many different methods, so I won't bother with this. Say here, I have put the data in an area which is my personal area where I can get information, say a couple of files that I wish to use in my experiments. So the same U drive now is available also here in this environment. And that's the key, because this environment here doesn't have access to the rest of the world. And here's the data that I would like to now check with my applications. I can go and say, and do a multiple analysis and click like here. At that point in time, this is the file that is very old, is activating the application. The application is Analyst 1.4.2. If you're curious how old it is, we can check. So this is an installation, a release of 2004. This is 16 years old. and the data is quite old as well. If I just want to see the data, I can click a couple of links here, and the analysis is in front of me. I can do this to any file. So the point here is that with this environment, we can create software installations that can then be used for often very kind of proprietary formats of thousands of documents. So creating a software library that has this effective access is absolutely key to continuing to use the digital archive that is so carefully retained, say, by bioanalysis in the sector. And just looking ahead, yes, there are many, many challenges, as Summer mentioned. And I just want to say we got very, very far, and there's still a way to go. But working together, I think we will make services of this sort commonplace. Thank you.
Thank you, Natasha. It's really fascinating to see the work being done in this area. But apologies to Marcel, who I forgot to introduce before. So Marcel is the co-chair of this session. And Marcel, are there any questions to Natasha?
Yeah, there are questions actually. Well, there was first question: is there a paper about this wonderful work you did, Natasha?
No, I have not published anything yet on the system, but we hope in the future. We're primarily focusing on practice, of course, and engineering behind, but definitely happy to share with the community and share know-how, because there are lots of intricacies involved in creating integrated environment like this.
Yeah, well, Adam added a link to your work in the chat. So in the chat you can also see some more information about it. Another question from Paul Stokes. Can an environment be spun up through an API call? So run the script and then return an output.
At the moment, the system doesn't expose APIs. This is all pretty much in an integrated environment that combines the virtual desktop delivery, which is maintained and supported by Citrix. And then on the back end, there is a Zen hypervisor environment in which applications are hosted. So creating an API for this is quite complex. Of course, if somebody just looks at the installations, access to installations, to be honest, is actually the easiest part. The hardest bit here is mediating all the intricacies of the security and exposure, because the virtual machines have to be spun out. We have to be able to close something if something goes wrong, meaning that if there is an attack on an operating system or anything, it needs to be very carefully monitored. Yeah, so in short, I think it'd be very hard to create APIs to interface with the whole system, but some parts, yes.
Okay. Thank you, Natasha, and really great work. And I hope that we will have a few minutes in the end of the session to potentially come back to some other questions. So I really see there are quite a few ones. But with this, I'd like to turn your attention to Adam Farquhar and Angela Tapper, who are going to be the next presenters from Digital Lifecycle Management. And they are continuing to talk about managing risk in long-term software installations. Adam, please.
Let's see, I think I need to share my screen. All right, good. So it's great to see so many of you here. The presentation I'm giving reflects work that's done by Angela Dappert and myself together with Natasha. Angela has made many key contributions to European digital preservation projects. A member of the British Library's digital preservation team, first head of research and practice at the DPC, serves on the Premise editorial committee and is editor of the book, Digital Preservation Metadata for Practitioners. I've spent 15 years or so with the British Library, where I founded its digital preservation team, founded the Open Preservation Foundation, led activities including the DPC Award winning Planets project. And this year, Angela and I partnered to establish Digital Lifecycle Management LLP, where we focus on digital preservation, but also AI, machine learning, and advanced technology applications. So today we're talking about this work we've done with Natasha at Intact Digital, and you've just seen an example of it. We're focusing on this very specific digital preservation challenge of enabling long-term use of software systems and data. And this differs from preserving digital documents or software alone. It emphasizes enabling people to use, interrogate, and inspect a software installation with its accompanying data. It's backed by a library with software data and knowledge resources required to use it. This is a really pragmatic, business value driven activity that's growing importance to commercial and government institutions, as well as national and university libraries, archives, and research institutes. I'll give you 3 typical use cases where we observe it to be highly relevant. I worked in the energy sector for a while. And, their companies conduct large-scale seismic studies to find oil or gas reserves. These studies are expensive, impossible to repeat, and produce large, complex data sets. Sometimes, in fact, it's decades before the technical, political, and financial conditions enable further exploration. You have to go back and resurrect the original systems for data analysis and export. In highly regulated sectors like pharma, companies need to demonstrate the precise basis for scientific claims like the efficacy of a drug using the original data and software. Finance companies may similarly need to explain loan decisions based on automatic systems many years after the fact. And all organizations need to retire legacy systems and data. This is a high-risk activity because new systems mess up data, core functions might be implemented incorrectly, and sometimes this is in ways that takes years to surface. So having confidence that you can go back to the original system and data and really reduces risk and cost. So taking advantage of new business opportunities, meeting regulatory requirements, improving operations, these are high value activities that can benefit from long-term software installations. So the rest of this talk is, I hope, for anyone who might be thinking about ensuring long-term access to software and data. Some of the risks around creating long-term software installations occur in most technical projects designed to deliver clear business value, but these projects and services differ in some important ways. They may be used infrequently, and most of the important use cases may not arise for years. And that means we have to adjust the way we think about how they return value. In addition, they may need to work for decades, which makes them highly susceptible to business and organizational changes, in addition to changes in technology and expectations of users. The risk you identify may be remote or unlikely. So it's especially important to have a robust risk management plan. We recommend a cross-functional team that conducts a thorough annual review with a smaller group holding lighter periodic reviews as escalating risks as needed. We have to consider also there are 2 quite distinct phases in this long-term software installations. There's that startup phase, we focus on discovery, it's a typical IT project. And second is this operational phase that can last decades. And here the focus is on managing and adapting to change. And we all talk about taking risks related to business and organizational change seriously, but in these types of projects, the risks, they will materialize. It's a matter of when, not if. A long-term access project requires you also to track many risks, so you need a framework for organizing them. We recommend grouping your risks into 5 areas. You have to ensure that the service reflects stable business drivers and values. It needs also to meet the long-term regulatory expectations as well as licensing demands. These projects have a high business value, but low and sporadic use, and that makes it even more important to ensure that there are good champions and there's good placement of the service within the organization. Even if your organization has the knowledge and skills it needs to build, deploy, operate, and use the systems in the scope for long-term installations, it soon won't. You have to identify and monitor the loss of those skills. So I've listed a few of the many technology factors that introduce risks. Simply identifying the scope of systems and components is challenging. Many risks are introduced by architectural and technical dependencies. The access service itself also provides challenges, and I'd really highlight the gap that will open up between users' evolving expectations and the fixed interfaces of the systems that are in the long-term installation. So these 5 areas provide a starting place to consider the many risks you need to efficiently manage and track over the service lifetime. So in our broader work, we've dealt an extensive set of applicable risks as well as checklists to complement them, and we'll hope to be writing that up during the course of the year. So often these projects will be connected to an old system, right? It won't use the latest technology or architecture. It will have been patched and rewired and rebuilt in flight. The documentation will be horrendously out of date. During discovery, you'll be talking to many people who were involved in those systems, and you're going to be asking difficult questions. And the answers may feel embarrassing. You really need to understand each person's connection to the system. You have to treat the experts, both technical and domain, right? You have to truly respect their contribution. And I think people often will say things like, well, I have no ego here. It won't bother me. Don't believe them when they say that. It's best to be upfront. These discussions always get awkward. Another real-life lesson is around enterprise components. Services like authentication or corporate databases, they make your IT estate more efficient. It's great, but they introduce dependencies. Furthermore, the choice of those enterprise services may change abruptly at the drop of a contract, if you will. You need to isolate your long-term installations from the enterprise services and insulate them from the effects of changes in them. Many of us have done acceptance tests, making sure services meet our requirements. In the long-term installation context, we should be making it as easy as possible for our service partner to determine if things are working correctly. Be sure that you can carry out smoke tests that they can carry out the smoke tests to broadly confirm basic functionality. I think it's important to note that over time, the balance of knowledge should shift towards the partner as we move further and further away from those old systems. Problems with time delays, I found super fascinating. Systems install clean, all the tests work, but then after a few days, uses or weeks, they demand, a license code that doesn't exist. It was last seen on someone's Post-it note. Maybe the original software supplier is out of business. Fixing problems like these takes some real deep technical expertise as well as diagnostic skill. So I'd like to conclude with a set of recommendations. Long-term software installations need long-term commitments. Plan for a decade, not a year. Use a structured approach to identify and manage your risks. Explain the software license, expect that software licensing is going to be ambiguous, and plan to absorb some business risk there. Transfer knowledge to the vendor before you lose it. You've moved on from this daily use of those systems. You don't need to retain the expertise. Plan for the service to outlast your current staffing and organizational structure, and plan for the day that users have lost all familiarity with every aspect of the system and how to interact with it. And lastly, capture and write up success stories and case studies and share them widely. They're the key basis for the future business decisions about whether to continue to run the service. So thanks very much for your attention. If you or your colleagues are thinking about building long-term access solutions, I hope that this discussion has been helpful. And now I'll turn over to the chair. Maybe we have time for one question.
Exactly. Thank you very much, Adam. Thank you very much, Angela. And Marcel.
Yes.
One question of your choice.
One question of my choice. Let's see. Well, can you clarify transfer knowledge to the vendor before you lose it? Shouldn't that be transferred from the vendor to?
So this is interesting. And actually, no, I meant what I said, although I've been called out on using the word vendor in this context.
Yeah.
But so here you are. You're in an organization. You've relied for years on a key software system to do, for instance, analysis and research. right? That's no longer necessary. You're archiving the system and the data in an environment where people can go and use it. So within your organization, you currently have expertise in how to use that system. Over time, the expertise within the organization will decay. And so you've got to have somebody, a trusted partner really, who will take on the responsibility for capturing and maintaining that expertise in an archival environment. So in 10 and 20 years, someone can come and say, okay, we've got to unpack that. How do we do it? They can help that person to unwrap it and figure out how to use and make sense of the system and the software.
Can I add to this? I think I have pointed out the confusion of the word vendor before. With a vendor, really, we mean a service that preserves software for long-term access, like Natasha's company. So it's not like transferring software back to the vendor that sold it to you, but making sure that we engage somebody like Natasha's company as early as possible and give them as much information as possible, so the competence is maintained at the source of preservation.
Yeah, thank you for that.
Thank you very much. That's really a fascinating topic. I can just very quickly comment here that also the Estonian public sector is looking very much into public sector services, virtual services, and how these could be preserved and carried on into the future. So I suppose there is a lot to talk about when we meet the next time. But now it's about time to move forward, and partially related to the previous comment on the public sector data and services. Next up is Kai Naumann from Landesarchiv Baden-Württemberg. And he is going to talk about 125 databases for the year 2080, a challenge and how it can be managed. Please, Kai.
Right, yeah. I'm struggling with setting the presentation free in the proper way. And now I have to choose which screen to share, and hopefully, oh my goodness. Messed it up. Well, I'll try again. Sorry. Can you bridge it by asking a question to Adam and Angela, please?
Indeed. Adam, your possibility. If you want to select something from the chat box, or Marcel, do you have the next one in line?
There was one question very early from Paul. What about the data? So you're focusing on the systems, but isn't it also about the value of the data?
Yeah. And maybe Natasha would be best placed to answer that, but I think that's it's absolutely correct. Long-term software installations are including both the software, the data that's being used with it, as well as the knowledge that's required to interpret the data and the system and use them together.
Thank you. Kai, how is it going?
No, well, the slides still don't run. I'll have to detach an external monitor and maybe that'll fix it. Sorry.
Should we continue with Paul?
Yeah, why not? Go for it. Yeah.
Paul, would you be ready to jump in?
Yes, I'm ready. Yes. So hang on a sec. I'll just do this.
And in the meantime, yeah, your presentation is your introduction is this Sorist, Paul Stokes from CHIS.
Okay.
And the topic is 3C, carbon costs of curation.
Now, hopefully, if I keep talking, this will flip to my face. Could you mute yourself for a second? There we go. Hopefully, you'll see me in a second. So 3C, the carbon costs of curation, which hopefully will pop up on screen in a second. If I do this, hang on. That's better. Oh, there we go. There. Okay. in case you're wondering about the logos, by the way, I'm Paul Stokes. I'm a director of OPF, chairperson of the company for the next 3 months. I'm also a director of the DPC and chair of the Advocacy and Community Engagement ACE Committee. Thank you, Sarah, for the acronym. And I work for JISC as project owner of preservation on what used to be called the Research Data Shared Service, and then the Open Research Hub, and now, well, now it's actually simply called JISC Preservation. So hopefully most people here will have heard of this, the 4C project, a collaboration to clarify the costs of curation. It took me a long time to get that right, but I got it right eventually. It ended 5 years ago, and it's still being quoted all over the shop, left, right, and centre. In particular, a couple of the outputs are being used widely. The curation cost exchange, it's still being used, being developed, and data is still being added to helping people to compare their costs with their peers. And the roadmap, interestingly on the roadmap, the vision in 5 years' time, in 2020, it'll be easier to design or procure cost-effective and efficient digital curation because it'll be understood. 5 years' time, that's about now. Are we there? Well, not quite. Hey, it was aspirational in those days, and it's still aspirational. But we know a lot more about costs now and how to model and calculate them. It's been clarified to an extent. However, there's a big but. What about the carbon costs? Very little work has ever been undertaken to understand the costs of the power required to both build and run the infrastructure that allows us to preserve digital objects, in particular the carbon costs of curation. So, a rhetorical question, you don't need to answer this because I will answer in a second. Do you know how much power is consumed by data centers worldwide? So is it 10 terawatt hours? No, it's not. Is it perhaps 50 terawatt hours? No, it's not. 100? Getting closer, but no. The actual figure that's widely quoted is about 416 terawatt hours. So that's a lot of power. And these are other figures you can pick up from literature here and there and everywhere. 3% of the world's electricity is used by data centers, and 40% of the total UK's electricity equivalent. And then Amazon's carbon footprint, a small country, well, yeah. And Ireland is the worst UK offender, worst EU offender, carbon offender. That's mainly because Ireland is a home for many, many data centers. Sorry, Natalie. So trying to contextualize that number, it's big, 416 terawatt hours. That's 416 with 12 zeros after it. That's enough to boil. I'm not going to try and say the number, but it's 1.04 times 10 to the 16 kettles in a year. And that's the equivalent of about 295 million metric tons of carbon dioxide. One scary part of this as well is that data centers are generally quoted as accounting for about 45% of the IT industry emissions. So that's about 653 million metric tons total. And how much of that is due to curation? Well, we don't really know. That's the short answer. The longer answer is we don't know a lot, but we know a little. We haven't really started thinking about how much data curation costs, but it's something we need to start thinking about because in the future it can become more and more important. There are a few things that are certain in this world of preservation. Data generation is increasing exponentially. We all know that. We'll run out of space eventually, but that's another story. And so theoretically, data preservation should be also increasing exponentially, although it will be lagging behind data generation because you don't preserve everything and there's curation involved in price selection. But it's something that there's always going to get bigger. So preservation and data storage processing will never decrease in any meaningful way. So what? Well, we need to start doing something about it. So what can we do? Well, to be honest, I haven't got any answers. I just looked at the numbers and got boggled, and I've got too much on my plate at the moment to do other things. But things we could start with, we could start by benchmarking to understand the problem. We could investigate the directly applicable carbon costs. It is possible to find out how much power is being used in the data center, and theoretically also how much power is being used by the curation aspects of it, the preservation aspects of your use of your data center. If those figures are being collected at sufficiently granular detail, and if they're not being collected in that way, they need to be. We can investigate the indirect carbon costs, the costs involved in producing the infrastructure, the embodied carbon in the machines we use, in the all the bits and pieces around the infrastructure and so on. And then we can take steps to curate, to alleviate the problem. We can curate, we can throw things away. We don't need to keep everything. We can procure renewable and low carbon services, and we can measure and see if we are making an impact and where we can make a difference and start doing it. And when we do that, we need to share that information. There's no good trying to do this in the isolation of your own little cell, or in Adam's case, a very nice office. But so share that information. And if you find information about this, if you start doing research about this, please tell everyone and tell me as well. Thank you. Questions?
Special thank you to Paul and keeping to exactly the time. Yeah, Marcel.
Yes, I don't see any questions yet in the chat.
I asked all the questions. I always got the answers.
Okay.
Yeah, you asked the questions, Paul. There is a link to one of the Digital Preservation Awards finalists. The research been done previous year on carbon costs.
Okay, but then I suppose it's the possibility for.
Yeah, another question from Andrea. How do we raise awareness that the carbon cost is a problem?
Well, we can start by things like this, raising awareness within our community, but also we need to start telling the powers that be, start telling the people who are making the financial decisions, the procurement departments, essentially shout from the rooftops. I don't have all the answers. Use every channel you've got, tweet about it, tell people. Those numbers are mind-bogglingly big, and use analogies to get people to understand just how big and how terrible that situation is.
No. Well, I do have an interesting paradox in the Netherlands. We have a national strategy for digital heritage, and well, one of the main goals of that strategy is having more collections digitized, more collections available 24/7 on fast storage for everyone. So what about that? Should we think about that, having all these digital stuff available?
Yeah, definitely. For one thing, does it need to be available 24/7 all the time at a moment's notice? And it probably doesn't. People need to accept the fact there will be delays in getting access to the information, because the other side of the equation is the carbon cost, the power cost.
Yeah.
Yes, and also in the public sector archiving, government archiving, business archiving, the main job of the archivist is to actually get rid of data, to find out what is the 90% of data you don't need in the organization or in a government, and what can you actually delete. So I'm just starting to wonder if this kind of carbon cost of curation would be a great selling argument for archiving and preservation in general, so including then also the destruction and offline storage.
Yeah.
Curation involves deletion. That's one of the key messages to get across.
Yeah, there's a perfect connection with our keynote this morning. Said it cannot be available 24/7.
Exactly.
Yeah.
That's me.
Preservation rebellion.
I like the concept.
Thanks, William.
Thank you, Paul. And now let's make a second try with Kai Naumann.
Yeah, another one.
Once more.
Now, I hope for a better result. This is crazy stuff. I see. Okay.
At least you can see your video.
Cannot as yet see my screen, can't you? This is full screen mode. I'm tapping on it.
Can you find the share screen button in Zoom controls?
Yeah, indeed, I'm trying to. I will switch off the one-person view, and now it may be easier. Screen sharing. It's like rocket science. Stop my video. Maybe that way. Oh yeah, there is something. One more minute. No, you can only see, you don't see the presentation mode of my presentation, and it's fairly small, but the type is good enough, isn't it? Oh, no, right now you're seeing a kind of a box with a
Vimi's TV press press agenda, but now we are back with the presentation. Yes.
You see the presentation. Brilliant. Okay, I'm going to talk about how to preserve 125 databases for the year 2080. Can you actually see the whole slide? Can you? In fact, you might just see a tiny bit of it, or can you see all the bullets?
There is the chat box on top of it, partially at least in my view.
Oh my!
The Zoom chat box, but I wouldn't worry too much about it. So just continue.
No, let me have another try to get at the best way of looking at them. That's the whole screen view. Now you should see everything. All right. We're a knowledge center about the past of the state of Baden-Württemberg, my employer. We are a key research infrastructure for the past. We save records of all kinds as cultural heritage, and we are a founding member of the DMARC development group. We've got over 100 partners from Austria, Germany, and Switzerland. The Landesarchiv's got a lot of sites, 9 sites. We've got an impressive budget. And I'll spare you with the other numbers except the 290 million dataset rows we already archive. So we are doing database archiving on a large scale. The challenge I've set up is how do you preserve 125 databases of diverse origin for future use from the year 2080 onwards? How do you prepare them in such a way that they can be used in as many ways as possible in 2080? And in the following 60 years, no cost should be incurred apart from secure storage, and the database contents must not be publicly accessible. I conceived the challenge in March during lockdown, and I disseminated it on mailing lists in April. And in August, I've already talked about it at the Joint Conference on Digital Libraries, and you can have a look at the paper, the state of the paper it had before I met you at Mimes iPress, and I'm looking forward to your answers on the challenge. There are 2 basic methods, and we've heard a lot about emulation today, but also there's migration to some robust format as a basic strategy. And we set up the challenge because as the Landesarchiv, we see that there are 2 competing methods right now, since emulation as a service has really had a rise in the last 10 years. And on the other hand, eArc, Karin Bredenberg will be amongst us, has made some progress as well on ZART, because they want to establish ZART as a European Union standard, or at least a specification. I've received 5 solutions so far. The CSV solution is the most common one. You choose the most important tables, or you prepare archival tables. You export them to CSV, you make an XML description of the fields and relations, you take screenshots of the graphical user interface, you add handbooks and tutorials for the database, and otherwise for the next 60 years you just wait. The XML solution is fairly similar. The only difference is that you don't store the data as CSV but as XML, and you might want to stick to the ZART schema doing that. And otherwise, you'd only wait for the year 2080 to come. And now the 2 emulative solutions. First one is to take disk images of the client hardware, take disk image of the server hardware. Then you'd have to preserve the necessary operating system environments and you might want to add handbooks or tutorials because it's not always easy to understand the database, how it's working. And then you do what Adam Farquhar has already explained. You have to check performance. You have to look at the risk that is implied with the strategy. Someone else told me to kind of refine it using Docker as the technology for your images, because this in the last 5 to 10 years has made it easier to construct the images you need. And then there's been one last idea that can only work for databases with a full web-based front end that displays a complete list of their objects. And for those databases, you could let a crawler translate all database content into a WARC file. And this suggestion also had had a mixture of strategies which I very much liked. That you could kind of let another crawler crawl the server as well, and you could also use the CSV solution on part of the data and use this for quality assessments. Otherwise, you'd have to wait. So to sum it up, I'm looking for ways to forecast the cost of the whole endeavor. And on this diagram, you can see the XML and CSV strategies in brown and blue in the front, and to the back, you can see the other 3 solutions. And I imagine that doing emulation is a bit more costly, represented by this larger surface of these silhouettes. And I'd really love to gain further insight from the client perspective. And it's great to have seen all the presentations about the vendor perspective on emulative services and other preservation services maybe as well. And if you reflect on our oldest holding, our oldest database is from 1961. It was populated on rented IBM machines, and they made 6 million individual punched cards, but most of them were destroyed in 1968 by a flooding. Those individual punched cards were lost, and the only surviving part were 1.5 million punched cards with calculated sums on every constituency, on every area of the land of Baden-Württemberg. They were migrated. They were only transferred to the state archives in 2006. And I wonder if we can do better for the 60 years to come. It is really unpredictable, but I can see that there are vendors out there, and I'd like to gather more answers on the challenge, and I will, with my colleagues, set up a workshop on the issue of database archiving at our site at Stuttgart in 2021. And now please discuss. Thank you, and sorry for the inconvenience I caused with my technical problems.
Thank you, Kai, and no worries. On the positive side, you were again exactly on time, so it's a pleasure to chair such a session. Marcel, any questions?
Instead of the technical issues, we're running on time. So there are a couple of questions. So there was the question Andrea pointed out, why wait 60 years? There was also an answer on that question, but still, why wait 60 years? Okay.
Well, it's because of our business model. Archives have the duty to withhold data from the public for some time because it's data protection issue. And the longest term we have been ruled by the lawmaker is 60 years. So I thought it would be reasonable to kind of be able to withhold it for 60 years. So we need services that make sure this data still exists, but not by volunteers, not by the crowd, because, well, data protection urges us to do it that way.
Okay, but is there any checking in between? So without giving public access, do you check software? Do you check the data in between? Because 60 years is quite a long span of time. And
well, in my view, we should have service contracts with companies or our own staff that do regular checks, and we would have to set up software that controls the emulation environments, I guess.
yeah.
I'm also personally interested in whether you think that a one and single approach to archiving databases is kind of feasible approach. So in the end of the day, we see all kinds of databases everywhere. So you have cloud services, single large-scale systems. You have systems which are more oriented on providing, let's say, end-user services through a user interface, through a web interface, through APIs. So is there actually a one and only solution which should be preferred? Or
No, I
would
don't
it be
think
trying
so.
to have it?
I don't think so. I would love service providers to offer mixed solutions. If you look at 125 databases throughout the administration of this country, they'd be fairly different. And I think a reasonable answer would be to kind of divide them into archival groups that fit, or to divide them into strategy groups, like databases where the GUI is really important. You do emulation, but for others you just CSV them, right?
Okay, thank you. And with this, many thanks to Kai. And we'll move on to the last presentation in this session, and that's Antonio Guillermo Martinez from LibNova. And he's going to talk about learnings from artificial intelligence applied to digital visualization. And I'm personally already very interested to learn whether it's going to be 2021 or 2025 when I'm being put out of job because the little artificial intelligence software pieces are doing all the work of digital archivists.
Right.
So please, Antonio.
Thank you, Kuldan. First, I would like to, well, I have two ideas for Kai for the database problem that I think may be useful for you. The first one is when you are preserving the CSVs or the XML, which in my opinion are the best among all the options, I would do both of them. I would also keep the original files in the package because it's going to be it's going to cost nothing to keep the original files. And if you have some problem when you are exporting all these database to an CSV and XML and so on, you will at least, and when you discover this in 60 years in the future, you will have at least the original formats someone could access to and solve. This is the first idea. And the second idea that you are not considering in the list, but I think it could make a lot of sense. I would not recommend that, but yes, for you to consider, is why not moving all the database to another database that is current? So using PostgreSQL or MySQL, something that is open source, but a database engine. So this way you would have all databases in a database engine that you would migrate over time, which probably would make a lot more sense than using Docker or other emulation technologies and so on. Just two ideas, if this could help you. So
Brilliant, thank you.
You're welcome. I will share my screen. Right. Are you able to see it now? Perfect. So, okay. So, as Kuldar said, I'm Antonio Guillermo. I am the CEO of LibNova. Many of you already know us. We are a major digital preservation solutions provider. We're working with customers like Oxford University, Hila at Stanford University, Oxford, the British Library, the Holocaust Museum, and we are one of the 5 selected companies worldwide to be part of the Archiver project, the Thorns Archiver project, on working how to preserve research data at scale. So, and our promise to the community is to provide the most advanced digital preservation platform existing. So this is the promise we are making to the community and to our customers. And to be able to do that, innovation is crucial for us. So we are devoting a large amount of resources to understand what's coming next and to start working in advance. Yeah. So 5 years ago, we created the LibNova research labs. We call them LibNova labs. That basically has been the output of this unit has been driving the company innovation since then. So we are basically, this unit is working on 4 innovation areas, and one of them is artificial intelligence and machine learning applied to digital preservation. So we have many successful stories. So we are starting to, we have been researching a lot over this technology, and we are starting to apply it to the products. We are starting to include it in the products and letting some selected customers to start using it and for us to learn about it in order to make it part of the whole products. So we don't have time today to cover all the areas that we are having success with, but I would like to share 3 key areas in which we are impressed about the results or key findings that we are having, because I think they make a lot of sense in the landscape. So the first one is that it's a key finding for me, is that we are implementing technology that we call explanatory artificial intelligence. So at the beginning, when we started implementing this kind of technology in the products, the technology worked really well, but we forgot a crucial thing, that is that the user is a key part of the process. So when thinking about automation and artificial intelligence, you usually tend to forget about the users, right, that are managing those systems. So even if the technology worked really well detecting things, the users managing it didn't understand what was happening under the hood, and the results were really bad. So we changed the approach to that. So instead of thinking on a tool that is going to do some process, and it's going to group basically the output on certain elements, the technology we are creating basically explains you the reason why the platform is making this decision or is suggesting you to make this decision. And this, what that seems extremely easy to do, is extremely complex to do in the real world, because basically the artificial intelligence or neural networks to a point work without you to know what is really happening in the model. So it is really complex for us to basically understand why the system is making some decisions or making some recommendations and guide the user through them. And by doing so, we have been having great success with in several areas. The platform is not only so the organization that is using the platform is not only achieving better results, but also the platform is learning from the user. So basically what we are achieving is a better platform, better decision-making platform in the future by getting the assistance from the user. When the platform fails to do something, the user is able to tell the platform that this is not this has not been done correctly, and the platform is learning from that, which is a key factor. So the why the platform is making some decisions is crucial for us, and we change it completely changed the development of this kind of technology in the product. The second is that this platform, this kind of technology in a platform works really well for anomaly detection. Right, so in digital preservation, in some cases, you are always looking for objects that do not look the same as other objects. So part of your ingestion policy, you will probably create some checks that are going to verify that the incoming data is aligned with a policy. But this is really difficult to consider, or really expensive to consider all the possibilities that you could have there. So adding an additional layer about a system telling you when something does not look the same as other objects that you have previously ingested, or other objects that are in the same package, has been extremely good for the organizations we are testing with, to the point that we are detecting a lot of objects that are misaligned or that are against the not defined policy in the organization. So, and we do that basically using adversarial network autoencoders. So we analyze 13 features for the content that you submit to the platform. This is all automated, right? So the system verifies, well, now we have like 30 something elements. I'm highlighting some of them here. The number of files that are part of the package, the files property extraction. So this means all the embedded metadata, for instance, for the files that are coming with them. The image, audio, or video content, basically properties, like content properties. So not looking at the container, but looking at the content that is inside the file. So if it's a black and white image, for instance, or if it's a what kind of quality, the blurriness of the image, and so on, we're extracting all these parameters to find the type of the image. We are extracting also the OCR content during the ingestion, and all the available metadata for the file. And the platform is then going to analyze all these factors, it's going to correlate them, and it's going to create basically an outliers kind of graphic like this one. So you get a very nice visual representation on what is, yeah, you have the core of the objects that you are ingesting, and you have some of them that are misaligned in certain properties, right? And when you select one of them, the system is telling you, something looks suspicious in the file format that you have in the object, right? So something is not aligned on this particular vector. So you can go and see the details and see why the platform is telling you that. Based on this, you can tell the platform, yeah, forget about it. This is right. So in the next iteration, the platform is going to take this decision into consideration, and it's not going to look it's not going to give you back this output and so on. And this is the way the system is learning. And the third key finding is the users, the organizations that are using this today are finding really good is that works really good is the automatic or automated metadata generation. So for instance, the platform is in a customer that is using it today is analyzing video and radio recordings, and the system is comparing them with another subset of data in which someone analyzed the data set and include the names of the ones talking or appearing in the video or in the audio file. So, and taking this knowledge base, the system is able to detect who is talking on them. This is the Nixon and John Fitzgerald Kennedy interview that was processed, and the system is detecting who was talking there and who was appearing them in the images and so on. In the data that, so in this customer, they are achieving a 99 something % of detection. So of the ones that are key, or the ones that have been included in the person's database that they were interested about. So we are applying the same concept to detecting other kinds of metadata. So like data that you may have in forms, kind of images, text under diagrams, tables, and so on. So we are applying the same concept to multiple kinds of content. And this is really nice, because when you enable it, this is free quality metadata, free of cost, quality metadata, and the
Antonio,
system is stable.
unfortunately, we are out of time in this session.
Yeah,
So
I'm
to
finished.
wrap
I
up.
finished. So I just finished. So thank you for that. You have my contact email there, so you can contact me if you have any question, or you can contact us if you want to have more information.
Thank you, Antonio. And though we are indeed already running into the next break, then Marcel, have you had any questions
Yes.
to Antonio?
Thank you, Antonio, for this wonderful presentation. Thank you for giving some insight in this developments. Are there any questions in the chat? I'm checking the chat now. Well, who is to blame that the AI makes a mistake? For example, making a private record public, deleting a vital record. What kinds of anomalies are you detecting?
Yeah, for the John question,
Yeah.
so who is to blame? This is a very good question. The first point is that I would not make the artificial intelligence in charge of first making a private record public, right? So I would never do that. And the second one is I would never include in a preservation platform the artificial intelligence capability of deleting content, right? So these are things you never do. So this is a first point about the anomalies that it is detecting. It is fine because you have no predefined list of anomalies that the system is looking. So the system is detecting objects that look in a different way. So if all the objects that you have in your archive are basically textual documents, and then you ingest a map, for instance, or a set of maps, for the first set, the system is going to tell you, this looks completely different to everything else that you have already in your repository, right? Because yeah, the system should do that. So a human would tell you that. So this is a new collection. The user would tell you. So the system does exactly the same. And then you tell the system, yeah, this is fine. We're going to ingest maps, or this is for another collection, shouldn't be there, or blurry images, or really small files. What is happening now? The resolution of your files is 10 times less than you have in your collection. So something is happening here, right? So please look at it. It's like a safe belt, right? So it's like this kind of technology that is really because you have a very little cost to have it running. Basically, it's embedded into the platform and gives you this safety belt. So it's telling you, this is something for you to look at. Is this kind of assistant the one that we are achieving great success?
Thank you, Antonio. And with this, I would also like to conclude this session, and indeed really thank all the excellent presenters. And I hope you all join me in having a quick clap and showing your appreciation.